guys, here are the answers to this worksheet. I'm going to go through it kind of quick and then some of it and then explain the others. If you have any other questions, just reach out to me and let me know and I'll get back with you. So on 17.1, which this was all participation by the way, so I'll send this to you once you've turned it in to me. Identify the following as organic or inorganic. Well, if it's organic, it's going to have carbon in it. So what I have is I have inorganic because there's no carbon. This one is organic. This one is organic. It's got that carbon in it. And this one is inorganic. 17.3, we're just going to know if it, once again, if it's organic or inorganic. Now remember, organic is carbon, it's oils, gases. Inorganic are like salts. There's other things, but that's what we're going to compare right now. Soluble in water. Well, think about this. Salts will dissolve in water. Oil will not. So soluble in water is going to be an inorganic compound because salts are inorganic and they dissolve in water. B, low boiling point. This means that it will boil at a very low temperature. Well, think about this. If I have a gas, gases evaporate quickly, so they're going to boil pretty quickly too. So low boiling point is going to be organic. A high melt or burns in air is going to be organic, and high melting point is going to be organic. All right, so give the name for each of the following alkanes. So I'm looking here, and remember when I'm doing alkanes and I'm giving names, my first step is going to be find the longest chain without picking up my pencil. All right, now I'm circling like this so you can see the chain. I mean like this, because I've had people in the past that, let me just put one down here, do this and they went and said it's 4, but that's not the case. All right, I'm just circling it so we can see what's in the middle, but this is what I mean. I'm getting my longest chain without picking my pencil up, and there are 1, 2, 3, 4, 5. 5. So even though it's all bent and everything, this is just pentane. B, just 2 carbons in a chain, so that is ethane. So you're giving this prefix of how many carbons there are and then ending it in A and E. And then this last one I have 1, 2, 3, 4, 5, 6. So that is going to be hex, and then I'm going to end it in A, hexane. All right, those are pretty simple. Nothing coming off of them, no branches. All right, so now 17.11. Write the condensed structural formulas for each of the following. So methane is literally just CH4. Meth means 1, so you have 1 carbon. Ethane is 2, so you are going to have, well here, I'm going to do this first. So ethane is 2, so you could do this. And now remember, each carbon has to have 4 lines around it. So it's going to be CH3, I'm going to have 1, 2, 3, I'm going to have CH3. Pent is 5, so and once you guys get better at this, you will be able to just be like, oh, it's going to be CH3, you're going to know when it's CH2, you're going to know these things as you practice. But right now, if you're not sure, I'm just going to draw out 5 carbons, and then I'm going to say, okay, 1, 2, 3, this one should have CH3, here's 1, 2, it should have 2 more, CH2, 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 and then the last one should be a CH3, it should have 3 lines around it. All right, number 17.13, indicate whether each of the following pairs of structural formulas represent isomers or the same molecule. Remember, isomers have the same molecular formula. It looks the same when you just look at carbon and hydrogen numbers, but it is a different molecule. So if you look at this one, that's pent, that's pent. Look, if I just rotated this one around this way, it would look the exact same as this. So these are the same. And if you're looking at B, this is actually 1, 2, 3, 4, 5. That's pentane, and this one's 1, 2, 3, 4. That one's butane. They are isomers. All right, even though this one's butane and this one's pentane, there's still 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5 carbons. That number of hydrogens would be the same also at 12. I believe the next one for this is down here. Let's look at C here. We've got 1, 2, 3, 4, 5. This is going to be a pent. We got 1, 2, 3, 4. This is going to be bute. So they are different, but 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. They have the same number of carbons. Sorry about that, guys. All right, they have the same number of carbons. All right, so they are isomers. They are not the same thing. They are different, but they have the same number of carbons and hydrogens. All right, so 17.15, I'm going to give the name, but now we're going to see where there are some branches coming off here. So I've got 1, 2, 3, 4. So this is going to be butane. And then I've got this branch. So remember, I'm going to count the shortest way to get to fluorine. So 1, 2. So this is going to be 2-fluoro. So the name for this is 2-fluoro-butane. Let's look at B now. I've got 1, 2, 3. So that is going to be propane. Now, no matter which way I count, if I go 1, 2, or if I go this way 1, 2, it's going to be the same. So it, no matter what, is 2,2-dimethyl. So I'm going to put it all together, and it is 2,2-dimethyl propane. All right, so on C, we'll do the same thing. Our longest chain is 1, 2, 3, 4, 5. So that's going to be pentane. Now, I'm going to count backwards because remember, I can pick this up and flip it around to where the chlorine is on the left-hand side. But right now, I'm going to go carbon 1, carbon 2, carbon 3. So I've got 2-fluoro. I want to count to where I can get there quicker, not 1, 2, 3, that way. And then 3-methyl. And now, once I have these, now I'm going to put them in alphabetical order. So it's 2-chloro, 3-methyl pentane. Once again, I'm going pretty quickly on this. You can always pause it, or if you are still unsure of something, let me know. 17.17, draw the condensed structural formula for each of the following alkanes. So I have 2-methyl-butane. I'm going to look at that butane, and I'm going to draw that out first. 1, 2, 3, 4. And then I've got 2-methyl. So on carbon 1, 2, I'm going to put a methyl group. Now I'm going to go back and add my hydrogens. Like I said, we need 4 lines, so 1, 2, 3, so it's going to be CH3, CH3, 1, 2, 3, 4, 1 carbon, 1, 2, 3, 4, 1, 2, 3, 4, so CH3. Now I'm doing this to show you how I'm getting it. What I don't want these lines on there. Eventually what I want you guys to be able to do is just write this like that, without having to put the lines. And if you need to put the lines right now, that's fine. Or at least maybe be like, in your head, be like, okay, I need 3 here. And maybe not draw them out. You'll watch me. If you watch me, sometimes I'll do this. And I will, or I'll do this, which is fine. But sometimes I'll just draw the carbon line and forget to put the hydrogens just because I'm trying to do it quickly. But remember, there's always hydrogens there. All right, B, 3,3-dichloropentane. So I've got pentane, so it's going to be 1, 2, 3, 4, 5. 3 on carbon 3. 1, 2, 3. I'm going to have chlorine, and it says dichloro, and they're both on carbon 3. All right, so notice you cannot just put 3-dichloro. You have to put 3, 3, that they're both on there. Now on here, I'm going to have CH3. This one, 1, 2, 3, 4. It's going to have CH2. Look at this carbon. It's got 1, 2, 3, 4 already. It doesn't need a hydrogen. 1, 2. This one's going to have 2 hydrogens. 1. This one's going to have 3 hydrogens. They all need 4 lines around them. All right, and then on C, I've got 2, 2, 3, 5 tetrabromohexane. So hexane's my main one. So I'm going to have a carbon chain of 6. 5, 6. All right, and then on carbon 2, I'm going to have 2 bromines. And then on carbon 3, I'm going to have a bromine. And 1, 2, 3, 4, 5. And on carbon 5, I'm going to have a bromine. Doesn't matter if I put them on top or bottom. We're not really caring too much about that. But this one is 1 line, so you need 3 more. So CH3. This carbon, 1, 2, 3, 4, good. 1, 2, 3, it needs 1 hydrogen. This one's going to need 2 hydrogens, 1 hydrogen, and this one will need 3. Once again, I'm getting these numbers by seeing how many more lines or bonds do I need around these carbons. All right. 17.19, it says heptane C7H18 has a density of 0.68 grams per milliliter. What is the structural formula of heptane? So let's draw this out. It is C7, so 1, 2, 4, 5, 6, 7. So I'm doing this to show you where all those hydrogens are. This would also be solid, liquid, or gas. I believe this one is a liquid. I believe it's only carbons 1 through 4 is a gas, and then all the way up to 18 carbons is, or up to 17 carbons, I believe, is a liquid, and then above that is solid. Is it soluble in water? No. No organic compound is going to dissolve in water. This would be like an oil type substance or a gasoline type substance. It's not going to mix in water. Will it float or sink? It will float. Water's density is at 1.0. Anything below that is lighter or less dense, and it will float. All right, and then at the very bottom here, these combustion equations, I'm just going to kind of write them out to the side here. I have ethane, so with combustion we have to do the molecular formula. That means there are no lines in this. So C2H. Now how I figure out this H, I'm going to take 2 times 2 plus 2. So it's 2N plus 2. That N is how many carbons I have. And in this case I have 2. So 6. Now for combustion, you're adding oxygen. You will make CO2 and water. And of course some energy. So remember when I said in the notes, the first thing I do is I balance the hydrogen. So I'm going to put a 3 there. The problem is if you have a 3 here that gives you an odd number of oxygens, I can never have an odd number on my reactant side. So I'm going to cross that out and I'm going to double it. This will always work. Once I've done that though, I've changed the number of hydrogens. I now have 12 on my product side. So I'm going to come back and put a 2 here to get my hydrogens. So right now my hydrogens are good. Second step is carbon. I have 4 carbons now. I'm going to do 4 there. This is why you have to do hydrogen first. If I would have done my carbons first, I'd now have to go back and erase all that. So 4 carbons. Now I'm going to do my oxygens. I have 6 and 8, so I have 14 altogether. So a 7 goes there. All right, for propane, that is C3. 2 times 3 is 6, plus 2 is 8. And I'm just going to fill out the rest of my equation here. All right, first step, hydrogens. I have 8 of them, so I'm going to put a 4 here. It's an even number, so I'm good. Now I can move on to my carbons. There are 3 of them, so I'm going to put a 3 on my product side. Now I can do my oxygens. 4 plus 6 is 10, so there are 5. Now I have 10 oxygens on each side. Now let's do octane, C8. So 8 times 2 is 16, plus 2 is 18. Fill out the rest of my equation. I'm running out of room there. Okay, so do my hydrogens first. That would be 9. I know I can't have an odd number, so I'm going to double it from 9 to 18. Now remember, I just doubled that. So now I have to come over and I have to double my hydrogens on this side. So right now I have 36 hydrogens on my reactant and my product side. Now I can move on to carbon. I have 16 carbons, so I am going to put a 16 here. Combustion equations can have some crazy numbers. You get some crazy high numbers. So carbons and hydrogens are good. I need to do my oxygens. So I've got 18 oxygens here. I've got 32 here. So there are 50 oxygens altogether. That means I would need 25 right there. And everything is balanced. That one is a little tricky. I know there's a lot of big numbers there. But anyways, that is the answers. I know I went through this pretty quickly. If you need anything else, please let me know. Have a great rest of your day.